Hello Year 4, how are you today? It's Miss Bellis here again. I hope you are well. And today we're going to continue our learning about position and movement. And we're going to be looking at plotting points. So here is today's in focus. And it says that Elliot has plotted 3 points. Here we can see them, A, B and C. He asks, where should D be for ABCD to be a square? How can we do this? What do we know about a square that would help us plot point D? Where would you put point D? Hannah asks, could ABCD be a quadrilateral, four-sided shape with one line of symmetry? So where could we put D to form a shape where if you cut it in half, it would be the same on both sides? She also asks, could ABCD be a rectangle? What do you think and why? At the bottom, it suggests, what if ABCD is a trapezium? What do you know about a trapezium? So Elliot's first question was where to put D to form a square. Ravi says it's at 3, 3. So let's check. Here is point D. We can see it is 3 horizontally and 3 vertically. So it is at 3, 3. And you can see that it has formed a square. Even though it's been turned or rotated, we can see it has 4 equal sides and 4 equal angles. The in focus also asked us about trapeziums. This is a trapezium. You can see that a trapezium is a 4-sided shape or quadrilateral that has one set of parallel lines. These are lines that go in exactly the same direction. Emma says D is at 5 something. So let's check. 5 is definitely our first coordinate, and the second one is 1 vertically. Charles here has put D at coordinate 0, 0. 0 units horizontally and 0 units vertically, and he has still formed a trapezium. It's a 4-sided shape with just one set of parallel lines. Holly asks, are there other ways to make ABCD a trapezium? What do you think? Where else could we move point D to form this shape? The in focus also asked if we could form a quadrilateral with one line of symmetry. Let's have a look. On this first one, D has been put here at coordinates 3, 2. This formed a kite shape, and we can see that if we cut this down the middle here, it would be the same on both sides. It wouldn't be the same if we cut across here, so we can see that it has one line of symmetry. If we look at this one, D has been put right up here at coordinates 3, 8. And again, it forms a shape with one line of symmetry. I could cut it here, and it would be the same on both sides. In this last one, D is all the way down here. It's a bit like the first shape, a kite shape, with one line of symmetry here. And Ruby asks, D is at what coordinates? Can you fill them in? So in the guided practice today, we need to plot these quadrilaterals, or 4-sided shapes, and it gives us the coordinates for the vertices or corners. And then we have to say what the shape is. So let's do shape ABCD together. So my first corner, point A, is at 1, 2. 1, and there's 2. Point B is at 2, 3. So along 2 and up 3. Point C is at 3, 2. I go along the corridor, up the stairs. And point D is at 2, 1. 2 horizontally, 1 vertically. And I think we can safely say if we joined that up, we would have a square. So here is today's worksheet, and it's very like the guided practice, but there are some different shapes. So figure ABC only has 3 vertices or corners, so you need to find points A, B and C, join them up and name the shape. So here are the answers. And here are today's challenges. As always, it's up to you if you do the challenges or not. Either is fine. So the first one has 1 point plotted on the grid, and it asks us what shapes could be made by plotting 3 more points. How many shapes can you find? The second challenge is a question. Amir asks, when you are plotting a point on a grid, it does not matter whether you go up or across first, as long as you do 1 number on each axis. Do you agree with Amir? Can you convince me of your answer? Okay, so today I also have a super spicy challenge if you feel like giving it a go, and it's a bit of a puzzle. So it's called 8 hidden squares. And as it says here, on the graph below, there are 28 marked points. These points all mark the vertices or corners of 8 hidden squares. Each of the 4 red points is a vertex or corner that is shared by 2 squares. The other 24 points are each a vertex of just 1 square. All of the squares share just 1 vertex with another square. All of the squares are different sizes. There are no marked points on the sides of any square, only at the vertices. So can you find the 8 hidden squares? It is a tricky one, but if you do give it a go, I'd love to see how you get on. So here are the answers to today's challenges. And here is the answer to 8 hidden squares. As always, the guided practice, worksheets, challenges, answers, and some graph paper are on the website. I hope you have a really lovely day, and I'll speak to you soon. Goodbye.